The customer's request is based on two parts to be identified. On the one hand, an automatic control of an electric valve from a fixed temperature value. On the other hand, a push button to set a state of the valve at the moment it is pressed. The first part requested by the customer, the valve changes state from 50 degrees Celsius. By pressing a button you can set a state for the valve at the desired time. In other words, if the push button is pressed while the valve is in one direction, it will remain in that state without checking the temperature until the push button is pressed again. The same will happen if the valve is in the opposite direction. The simulation has two LEDs to visualize the different possible states. One represents the direction of the valve with states on or off, and the other represents whether the control state is in automatic mode when the LED is on. In other words, it depends on the temperature, or fixed when it is off, leaving the valve in the direction chosen at that time. The different states of the valve are controlled by a relay. During the simulation is only observed that can turn off or turn on the LED corresponding to the simulation of the valve. The circuit consists of an Arduino one where the control logic is housed, a DS18B20 temperature sensor with a pull-up resistor of 4.7K indicated by the manufacturer, a push button to set the desired state with a pull-down resistor, a 5V relay with a diode 1N4001 protection, a 2N3904 transistor to activate the relay, and a LED to indicate the automatic enabled/disabled state of the firmware. When starting the simulation, we can change the temperature values in the same diagram. If the temperature reaches or exceeds 50 degrees, a change of state is clearly shown on the LED. On the other hand, if the temperature drops below 50 degrees, regardless of the state of the valve, when BTN1 is pressed, temperature changes below or above 50 degrees can be performed without generating changes in the state of the valve simulation. We can see this example in both directions, with the simulator on or off. We can also clearly see the change of state in the LED that indicates whether the current mode is automatic or not.